Ladies and gentlemen, I'm pleased to welcome you here at the technical forum of the group exhibit Hydrogen Fuel Cells, and for the first time this year with batteries. Please come in, have a seat, have a drink on the house and enjoy with me our next presentation. So dealing with the topic HYMEHC-x, the thermal metal hydride compressor by Hystorsys. And your presenter is the marketing and sales manager from Hystorsys, Björn Skúlason. Give him a big hand, please.
So, thank you very much. I'm going to give you an insight into a new way of compressing hydrogen by a thermal hydrogen metal hydride compressor. But if we begin a little bit to introduce the company, which is not very known. Actually, it's established in 2005 by Institute for Energy Technology in Norway, the Keller Innovation also in Norway, and Jon Eriksson, which is the managing director. And the owners of the company are Norsk Innovasjonskapital, Prototech, and also the CEO. And we're based at the Institute for Energy Technology in Norway, where we have a lot of support regarding our research on metal hydrides and other components of the compressor. The core competence of the company is, of course, the metal hydride composition. It's based on very long research at the Institute for Energy Technology. We have a lot of capabilities regarding their characteristics and the field of utilization, synthesizing and optimizing and modification. And for a period of time, we looked quite a bit into using metal hydrides also for storage. Just as well, we were looking into using it for compression, but our current focus is mostly on the compression side. And therefore, we have a lot of knowledge throughout our last 5 years of research. We know a lot about system integration and how to integrate our compressor to other applications like reformers or electrolyzers and so on. And of course, we know how we can use metal hydrides and or combine our metal hydride compressor to, for example, bottling of hydrogen. I'm not going to spend a lot of time on metal hydrides. I don't know how much you know about metal hydrides, but of course we take different types of metals or alloys, which we make into powder. But the main issue with metal hydrides is that the hydrogen is chemically bound to the metal at an atomic level, and thus the hydrogen is no longer volatile as it is in the gas phase. So that's a very important factor. Another very important factor is that anything you put into the metal hydride is going to sit back there except the hydrogen. So if you have any kind of impurities in the hydrogen, it's all going to be stuck in the metal matrix, and therefore you're always going to get an extremely pure stream of hydrogen out of the metal hydride compressor. So in a sense, it can also work as a perfect purifier for hydrogen. In a sense, it's not very complicated what we are doing. We cool down the metal hydride. We have these tubes. Inside the tubes, we have heat exchangers, which is, of course, one of the key issues, the design of the heat exchangers to distribute the heat within the metal hydride. So we start by cooling down the metal hydride, and then you put in low pressure hydrogen. And in a sense, after you have filled up the hydride, you close the valves, you heat it, and you have high pressure hydrogen coming out. So you can do this in different stages. So it's a relatively simple process, cooling and then heating. And you can do it stage-wise. You can do 1 stage, 2 stages. We could even do 3 stages. So each stage, depending on, of course, the temperature difference between the cooling side and the hot side, will determine how efficient we are and how much we can increase the pressure. We installed the first compressor as a proof of concept in May last year at the Heinor Lillestrøm hydrogen refueling station. So we actually, in that sense, we're taking hydrogen in at 10 bars, 10 cubic meters an hour, and we compress it in 2 stages to 200 bars. It's actually a perfect platform to test our compressor. This is a location where a lot of Norwegian technologies have been able to. It's a research park, so we are testing all kinds of different Norwegian technologies there. And this gives us a lot of room and time to play around and understand all the issues regarding the compressor. So it's actually been working quite well. And of course, the achievement of getting a proof of concept up and running, we have to thank the Institute for Energy Technology, Prototech, and the Norsk Innovation Capital, which have all been very patient and helpful in doing that. The hydrogen station in Lillestrøm is actually a 700 bar station, so it delivers hydrogen directly to 700 bar vehicles. So we actually compress to a buffer storage, and then there's another compressor taking the hydrogen to 840 bars, and then of course refueling in 3 minutes any kind of 700 bar station. So this is a public open station. As you can see there, we actually have here a full-size hydrogen station from H2 Logic, which actually could take hydrogen all the way. But this is actually the research park where different types of technologies have been installed. And our compressor is actually located here, and we have buffer tanks within the station to take our hydrogen. And our compressor, this our proof of concept compressor, looks like this. And we have also now installed another compressor, which is half the size. So that's running now at Nel Hydrogen Research Park. So we have done quite a bit of work over the last 2 years in understanding all the difficulties of the compressor. So in a sense, you have 6 different types of cylinders. One is always being cooled to absorb hydrogen. One is always being heated to increase the pressure, and one is always either absorbing or disabsorbing hydrogen. So it's a continuous flow through the compressor. So this is actually a 2-stage compressor. So a 1-stage compressor does not need, of course, 6 bottles. The unique features, as I mentioned, is the very high gas purity of the metal hydride compressor. There is, of course, a much lower maintenance failures because there's no moving parts, more or less. You only have a couple of valves moving, so if you have thermal energy or waste heat or geothermal power, in a sense it's an extremely energy efficient compressor. It is totally silent, so there are no moving parts, so it's fully silent. You could place it here beside us here and would not interfere with my discussion. It has very high safety, and it has flexible installation. It does not have to be set up in the way I showed before. So it doesn't have to be in this configuration. You can actually configure it and put it on a wall or design it in any way which fits the application is being used for. So that's another benefit for a potential customer. So as I said, we have 2 in operation. We call them HYMEHC. So HYMEHC-x means X stands for how many cubic meters an hour. The 2 ones we have are 5 and 10 cubic meter, but we have designed them all the way up to 50 cubic meters. But what we are looking at as the first market entry is relatively smaller scale, so anywhere between lower than 30 cubic meters an hour is our targeted market. It's a fully in-house designed and developed, and it's created and built with our partners, Prototech, IFE, and Aquagas in Sweden, which actually is the constructor of the compressor itself. Our near-term achievements have been drastic cost cuts, which have been very important, of course, and our main goal. And we have seen a lot of thermal energy use, much better thermal energy use, which is also very important regarding the efficiency of the compressor. We have developed more partnerships, and we are, of course, open to other partnerships, for example, with electrolyzer companies, reformer companies, hydrogen backup providers, and other types. So that's we are really interested in increasing our partner group. So in a sense, if we have 3 times 250 bar steel vessels for each of the 2 stages. Each vessel contains about 34 kilograms of metal hydrides. We have AB5 alloy as the first stage, taking the hydrogen in our case from 10 to 70 bars. The second stage is an AB2 alloy, taking the hydrogen from 70 to 200 bars. And there is an efficiency correlation between the delta T. So for us, the difference in the cooling and the heating is the key issue of the efficiency. We can go down to 60 degrees, so in a sense compress hydrogen if the delta T is 60. Our preferred heat would be somewhere between 75 and 95 degrees. That would be the ideal compression ratio. So as I said, the main findings over the last 18 months since we actually started building the first one, we've done a lot of technological improvements, but the main issue has been drastic cost savings. So we're getting very close to the same cost level as everybody else, but we have, of course, these unique features, which I mentioned. Just to show you what kind of research and development we've been doing, the key issue for us is how efficient the heat exchanger is working. So these are just test figures about how fast we actually are in reaching different temperatures. So you can see here we're going from the metal hydride bed from 20 degrees to 90 degrees in less than 1 minute. So that is a very important feature of how fast we can actually get the hydrogen flowing through the system. And the same with the cooling. When we cool it down, we're actually getting the metal hydride down to 20 degrees in the cooling period in just around a minute. And that, of course, directly then affects the absorption rate and disabsorption of hydrogen. So if we get the cooling fast down, the absorption of the hydrogen can happen very quickly. And the same way, when heating, the disabsorption is the same way, and that affects the cycle life of the metal hydrides. So the faster this can actually happen, the more hydrogen we can compress. And this, of course, also has impact on the lifetime of the whole system. So this was our first demonstration, 10 cubic meters, input pressure 10 bars, output pressure 200 bars, 2-stage. And we welcome you, if you are in Norway, to come and visit us. And we can, of course, show you the hydrogen filling station and all the technological developments at the Hyner Lillestrøm station. And actually, there's a lot of things happening in Norway at the moment. And this is just one of 7 filling stations which are in operation in Norway for vehicles. We also did another project called Hybrocom, which was funded through a European program. We developed, the project goal was to develop and integrate natural gas-based hydrogen production and compression system using steam methane reforming and metal hydride thermal sorption compression. So that was a 5 cubic meter an hour, 250 bar. The Hybrocom project is actually finished, and the compressor we delivered, we unfortunately were a bit late, so we're still keeping it running to continue the data collection, which we are sharing with all the partners in the project. And that's a very vital thing that they understand, even though we were a bit late, that we are actually executing everything we were supposed to do in the project, and so we're still running the compressor. So as a conclusion, the last 5 years have been a very steep learning curve. R&D activities and cooperation specifically with IFE, and IFE is a very important factor on the metal hydrides. There's a lot of knowledge on metal hydrides in the institute. We have developed the HYMEHC thermal compressor, and in a sense we are at the stage where we are fully ready for commercialization and delivering components. And we are discussing with many of the partners to actually starting installations of different types of compressor. And of course, what we are offering beyond many others is it's silent, it's scalable, almost no moving part, very flexible installation, utilization of waste heat or geothermal heat, and guaranteed gas purity, which is very important for many customers in the hydrogen sector. So I welcome you to if you're interested in projects or partnerships, and to see us. We are here at the exhibition, and we are really open for business. And I would like to thank the Norsk Innovation Capital for their support and patience with our project. And thank you very much for your attention.
Thank you very much, Mr. Skúlason, for this very interesting presentation. Are here any questions around in the audience? Just yes. Would you be so kind to introduce yourself?
Yeah, hello, my name is Dennis, and I started studying ecotechnology. And my question is there a lifetime of the metal hydrides?
Yes, of course there is a lifetime issue with the metal hydrides. As I mentioned, if you feed very pure hydrogen, the lifetime is longer than if you feed very impure hydrogen. But we are guaranteeing a minimum of 4,000 hours of operation. Then of course you can easily exchange the steel bottles, and we will recycle the metal hydrides. So it's not like you're buying a whole new system. So at least we're guaranteeing 4,000 hours, but our lab tests are indicating actually a longer lifetime. but it depends a little bit on the purity of the hydrogen. But minimum 4,000 hours of operation, yes.
Are there any other questions right now? So, not yet. No.
Régis Anguillante, AFE. I would have a question about the alloys you used in. Do they have rare earth or not? Because, like, you have very the prices of the rare earth vary a lot, and well, I think. So if you could be more specific about the alloys you use in the metal hydrides.
Of course, one of the key features is that the composition of our metal hydrides is something we don't want to give out in details, except for the AB2 and AB5. But we have found various suppliers of the metal hydrides, so it's not like that will be a complicated system for us not to get the alloys. And actually, the alloys for the metal hydride compressor is not a very big component of the total cost of the compressor. So we of course try to avoid rare earth materials, but of course there is some in the compressor. So, but there are supplies coming in, and we are discussing with partners from actually 3 different continents for the delivery of metal hydrides to the system. And of course it's important for us that we can recycle all the metals we're using, and that's why we would like to see in the service life that even though you have to remove the bottle or the tubes with the metal hydrides in it, that our goal is to be able to recycle all the metal hydrides and reuse them in the future. But you can, if you want to have a little more details, you can visit us to the booth.
Okay. Are there any questions right now? So then, like you mentioned, I would invite everyone who want to discuss face-to-face with you or have questions in more detail to come to your booth. It's D62. It's here at the group exhibit.
Yep.
So don't hesitate and come, and I think you will warm welcome everyone.
Yes, we do.
Yeah. Okay.
Thank you.
Thank you very much.
Thank you. Thank you.
So we will continue our program in 7 minutes with the topic Membranes, the central unit of energy storage and generation.